Hello everyone, welcome to Kamaraj College of Engineering and Technology YouTube channel. I am Dr. T. Dhanlakshmi from Department of Chemistry. In this video, we are going to discuss about boiler troubles. We know what is a boiler, that will be used for the production of steam in thermal power plants or in simple tea shops where we can see the boilers. So this is boiler feed water. This is the diagram for boiler. So here water will be input into the boiler and it generates steam. So this steam is used for running the turbines in a normal power plants. So this water is called boiler feed water because it is fed into the boiler. So this boiler feed water should be free from turbidity, oil or dissolved gases. So if it contains all these, it will cause some troubles. So in this video we are going to discuss about these boiler troubles. So first we will see the requirements of boiler feed water. So when you are using water in the boilers, it should have some qualities such as dissolved oxygen, it should be less than 0.02 milligram per liter, hardness it should be less than 0.5 ppm, phenolphthalein alkalinity it should be 0.5 ppm, methyl orange alkalinity 1 ppm, iron, copper and silica they should be in minimum amounts. If these requirements are not met, it will cause some troubles in the boiler. That is we are going to see in this video. So boiler troubles, there are 4 troubles as usually you can see from these pictures. There are some deposits on the boiler parts. This is called as boiler troubles. So we will be having 4 boiler troubles: sludge and scale formation, priming and foaming, caustic embrittlement, boiler corrosion. Sludge and scale formation is due to the presence of dissolved salts, priming and foaming is due to the presence of oil or grease, caustic embrittlement is due to the alkalinity in water, boiler corrosion is due to dissolved oxygen. So we are going to see elaborately. First, scale and sludges. When water is continuously boiled, water evaporates, so it leaves some precipitates. So when the boiler is working continuously for 24/7, these salts deposits when we are actually using hot water in the boilers. So it results in the formation of scale and sludges. We will describe the characteristics of scale and sludge. So first, sludge. Sludge is a soft, loose and slimy precipitate. So it forms on the colder portions of the boiler. So it is formed by substances having greater solubility in hot water. So that is, they are insoluble in cold water. When you switch off the boiler, they will automatically settle down. They can be easily removed with a wire brush. Next, scale. Scales are hot substances. This can be seen as well as in our homes also. When you boil the water obtained from bore wells, some white deposits will be there. So it will be hot to remove. So like that, in boilers also this scale formation is happening. So this is due to calcium sulfate, calcium carbonate, magnesium hydroxide. So this causes hot deposits. It can only be removed by chemicals, that is 5 to 10% HCl or by adding EDTA. So next we are going to see priming and foaming. So these are also called as carryover. That is, sometimes when the water boils, steam is generated. This steam carries over some dissolved particles in the water. So they automatically settle down on the turbine blades. This decreases the efficiency of the system, that is power plants. So they have difficulty in generating electricity. So these droplets of liquid water carry with them some dissolved salts. The formation of wet steam, that is steam containing liquid water, is called priming. So the process of wet steam formation is called priming. So priming is caused by lot of factors. First one is presence of large amount of dissolved salts. Next, high steam velocity. So unexpectedly when the boiler is heating strongly, so steam is generally produced more. So automatically it will carry over the liquid water. Very high water level in the boiler, improper design of the boiler, sudden boiling of water, sudden increase in steam production rate. So how you have to remove priming? It is done by avoid rapid change in steaming rate, maintaining low water level in boilers, efficient softening. Softening in the sense removal of dissolved salts from the water and filtration of boiler feed water, fitting mechanical steam purifiers. That is a mechanism where the water will be separated from the steam. Next we are going to see foaming. Foaming is the formation of gas bubbles on the surface of the water while boiling. So, these bubbles will not break. So, it have a lot of bubbling in the surface of water. So, automatically steam will have more liquid water droplets. So, this is due to the presence of oil, grease and the finely divided particles. So, this foaming can be removed by adding certain anti-foaming chemicals like castor oil that will not form any bubbles. Otherwise, by adding coagulants that will deposit oil or grease like sodium aluminate or aluminum hydroxide. So, they remove oil from the boiler feed water. Next, we are going to see caustic embrittlement. So, this is a type of boiler corrosion. From the word itself caustic, it shows the presence of high alkalinity in water, that is caustic soda or caustic potash. We will be having it as NaOH or KOH. So, the presence of NaOH is called as caustic embrittlement. So, normally water usually contains a little amount of sodium carbonate. In the high pressure boilers, this sodium carbonate is decomposed to give sodium hydroxide. So, the water will have sodium hydroxide. When the water is continuously evaporating, the concentration of NaOH increases. So, this NaOH it flows into the cracks in the boiler material. Normally, a material will have small minute voids or cracks. So, this NaOH will flow into that and it also reacts with material of the boiler. For example, if it is made of steel, it reacts with iron and it dissolves the iron. So, it ultimately results in the cracking in the boiler material. So, this is called as caustic embrittlement. So, the principle of working is similar to concentration cell. That is, the water inside the voids will have high NaOH concentration, outside will have a low NaOH concentration. So, it creates a potential and ultimately results in corrosion. It is otherwise called as caustic embrittlement. So, removal of caustic embrittlement, this is removed can be avoided by using sodium phosphate. That is, in sometimes for water treatment sodium carbonate is used, but if you use sodium phosphate, the caustic embrittlement can be removed. Next, by adding sodium sulphate, actually this also results in addition of extra salts, but anyway it does not form sodium hydroxide. Then by adding ternine or lignin, so these substances will act like a paste and it covers the cracks in the boiler material. So, that is all for now. Thank you.